Hello everyone. Today we are diving into the fascinating world of computer networking, especially exploring network address translation. This technology plays a critical role in how devices communicate on the internet. But what is NAT and why is it so important? Let's find out. NAT is a method used in computer networking to modify the source or destination IP address of data packets as they pass through a router or firewall. It acts as a translator, allowing multiple devices in a private network to share a single public IP address. This helps conserve the limited number of IPv4 addresses and enables seamless communication between private and public network. NAT comes in three main types: and static NAT, where there's one-to-one mapping between private and public IPs, often used for hosting servers. Dynamic NAT, an unregistered IP address is translated into a registered public IP address from a pool of public IP addresses. Assign public IP from a pool. Port address translation maps multiple private IPs to one public IP using ports. Now we are analyze the key concept of NAT. Public IP, a unique IP address assigned to device or network that is accessible over the internet. There is some example: the ranges of public IP and private IP, an IP address assigned to devices within a local network not accessible directly from the internet, used for communication within the same local network, home or office. Here is the range of IPv4 for private IP ranges. Now we are discussing about difference between public and private IP. Aspects of scope of use: public IP identifies devices globally on the internet, and private IP used within local networks. Public IP must be unique across the internet, and private IP can be reused in different networks. Any IP not reserved for private use and reserved ranges of private IP 192.168 to 10.255 and directly accessible from the internet is public IP, and private IP not accessible directly from the internet. Public IP connects networks to the internet, enables communication within local network. How NAT works. Now we are talking about the steps how NAT works. And packets sent from internal network, the private IP. A device in the internet network sends a packet to external destination like a web server. NAT router receives the packet. The router identifies the packets as originated from the private network. Since private IPs cannot route on the public internet, the NAT process begins. Source IP translation. It means private to public transition. The router replaces the private source's IP with its public IP. Translated packets. Here is the source translated into the IPv6. Destination is 4 octet using 8.8.8. Packet sends to the destination. The modified packet is forwarded to the destination server 4 octet for 8, and the server responds to the packet. The server sends a response packet to the router's public IP. Response packet is source to destination IP, and router translates back It means public to private transition. The NAT router identifies the port and the maps it backs to the original private IP. The destination of the packet is updated to the private IP. Translated response packet, here is the translation response packet, and packet delivered to internal device. Here is the full process, the scenario and step by step translation. It's become easier if you fully concentrate in this scenario, and it's easy and simple. Why we need NAT? Save IP addresses. The internet has limited IPv4 addresses, and NAT lets many devices share one public IP. Allows internet access for private IPs. Devices with private IPs can't directly access the network. The NAT makes the possible by translating private IPs to a public IP. NAT hides private IP addresses from the internet, making it harder for hackers to target individual devices. Simplifies networking. NAT lets multiple networks use the same private IP ranges without conflicts. Work with old systems. NAT helps older IPv4 systems keep working while the internet moves to IPv6. Now we are talking about the advantages of NAT. It conserves the public IP address. It enables the multiple devices to share a single public IP address, conserving the limited pool of IPv4 addresses. It improves security. It is harder for external attackers to target individual devices. It is its flexibility in network design. NAT allow private networks to use any internal IP address schema without concern for conflicts with global IP addresses. Support legacy IPv4 systems. It supports using the IPv4 by reducing the need for additional public IPs. Now we are talking about the disadvantages of a NAT. Performance overhead. Translation IP addresses adds processing overhead. It's a high traffic environment, and debugging issues in a NAT environment can be over challenging because it hides the internal IP address, complicating log analysis and diagnostics. Compatibility issues. Certain application or protocols such as IPsec and FTP may require additional configuration or workarounds. Incompatibility with IPv6 core. To wrap up, NAT is more than just a networking term. It's a powerful tool that has shaped how we use the internet. By conserving IP address, enabling secure communication, and providing flexibility, NAT remains an essential technology in today's interconnected world. Thank you for watching this presentation. I hope you now have a clearer understanding of network address translation. If you have any question, feel free to ask, and see you next time.